It takes an elevator 16 seconds to ascend from the ground floor of a building to the 6th floor. The velocity of the elevator during its ascent is given by this velocity just here. V is in meters per second, t is in seconds. Determine the acceleration of the elevator during its ascent and provide a sketch of the acceleration function. So we know that to get the acceleration we're going to differentiate. So that's going to be 9 pi by 16 cos pi t on 16. And don't forget to use the chain rule. So we'll have a pi by 16 here, which is going to give me 9 pi squared over 256 cos pi t by 16. Now, it's going to take longer than is ideal for 2 minutes to do this well, but sometimes you just have to do it. And you can see I've already put the function in here. And what I'm going to do is produce a table rather than the graph. So I'm going to produce a table, and this is actually set up quite nicely for me in that I was going to start 0 and go up in 2s. So 0, I've got 0.347, so that's going to be sort of around here. And 2 is 0.32, so it's probably around there. And then 4, 0.245, so actually 0.347 would probably be a bit higher there. And 0.32 is going to be sort of there. And then 0.25 is probably about here. At 6, we have got 0.13, so probably about there. At 8, we've got 0. And then we've got negative 0.13, so probably around there. Negative 0.245, so somewhere around there. Negative 0.32, and negative 0.35 is probably about there. So we know what a cos looks like. So it's probably going to look something like that. And I should of course end it at 16 seconds. So, with reference to the answer from part A, explain what's happening to the velocity of the elevator in the interval 0 to 8 and 8 to 16. So, what's going to happen along here? So, it's accelerating, the acceleration is positive, so along there it's always getting faster, and the acceleration here is negative, so that's when it's slowing down. And if we look at this, it's getting faster, but the acceleration is decreasing. And here the acceleration is increasing, but of course, or when we say the deceleration is increasing might be better. So deceleration increasing because it's getting more negative. So the rate at which it's slowing down is increasing as we go there. So suppose the ground floor has displacement x equals 0 meters. Determine the displacement function of the elevator and hence determine the height above the ground floor. Well, we know that the velocity function was 9 pi by 16 sine pi t over 16. So the displacement function is going to be 9 pi by 16 negative cos pi t by 16 divided by pi by 16. So that's going to be 9 pi by 16 times 16 over pi. Bring the negative there, and then we've got cos pi t over 16, and of course plus a constant. So those pi's are going to cancel, the 16s are going to cancel. So x is going to be negative 9 cos pi t on 16 plus constant. And we know that x equals 0 when t equals 0. And so 0 is going to be negative 9 because the cosine of 0 is, of course, 1 plus c. So c equals 9. So x is going to be equal to negative 9 cos pi t on 16 plus c. So we want the height above the ground floor of the 6th floor, and we know from the beginning of the question that that happens when t is 16. So x is going to be negative 9 cos pi plus c. Cos pi is negative 1. Sorry, the c, of course, was 9. And so that is going to be 9 plus 9 is 18 meters.